this session for the impulse. Today I will explain you what is impulse and impulsive force. Before going to impulse, we must know that force is equal to mass into acceleration, right? So force, and also force is expressed by dpdt or ma. So dpdt means rate of change of momentum. So the symbol p is presenting the momentum. Momentum is a vector quantity. It's the product of mass and velocity. When object is in motion with having a mass, so we are getting a new property called momentum. So if the object is heavier, in that case momentum will be higher. Even if the object is in high speed or high velocity, right? So momentum will be higher. So it's a vector quantity, the product of mass and velocity. This is momentum, and always keep Newton's second law with you. Newton's second law told that, it defined that there is a change in momentum. Whenever there is a change in momentum, that caused due to a force. To change in momentum, we need a force to apply. And how we are quantifying the rate of change of momentum is proportional to the force applied on the object, and this change of momentum will be happening in the same directions where force are applied. Okay, this is Newton's second law. Now next, go to the next slide. uh, this one is impulse. Yeah, impulse. So impulse means whenever we are having a large force acting for a short interval in an object, we are saying it's an impulse. Like a large force acts for a short interval, that cause the impulse. So impulse, the symbol of impulse is J. J is equal to F into T. F is the force, and T here actually be defining the delta T, the short interval of time. Example, like, in case of boxing, the boxing punch, that's happening in a short interval, like, hit in the cricket ball. The cricket ball is getting hit by the bat for a short interval, and that time that force is in high value of force acting for short time. Okay, so whenever we are having the situation where high amount of force is acting for short interval, we are saying like in collision. If two hard balls are doing collisions for short interval of time, so that will be an example of impulse. Okay, so fine. So this is impulse. Symbol of impulse is J. It's a vector quantity. It means force into time, and force into time presenting the change in momentum. So one more thing we will get from here, that is the impulse momentum theorem. Okay, I'll come to that. And SI unit of impulse is, Newton second, or Newton per second, you can say, like force into time. Force into time. Unit of force is Newton and time is second. So you are saying it's an Newton second. Fine. Okay. Now let me go to one more slide we have on this part, right? Okay. Yeah. I'll show you this part. So this derivation we have, where we know that impulse momentum theorem. So what happened, that we know that force is equal to rate of change of momentum. Now from here we'll be showing you that, impulse is the change, impulse presenting the change in momentum. Change in momentum. So this is called the impulse momentum theorem. If you see here, we just did dp is equal to f dt, because f is equal to dp dt. So I can write dp is equal to f dt. Now, so dp is equal to f dt. Now we are going for integration. So dp means small change in momentum, and the range value is p1 to p2. That means whenever you are applying the force, let the change of momentum happen from initial P1 to P2, and that cause, when the momentum was P1, the time, initial time, let's say t is equal to 0, and when momentum is P2, the time is t. So this way, if we integrate both the sides, we will get that, f dt is equal, f into t is equal to P2 minus P1. Okay, so Let me also explain in the board. I hope it will help you for the derivation part, right? Okay, fine. Now, as we discussed, force F is equal to dp dt. So this is force, this is momentum. So force is rate of change of momentum. Now from here we can write dp is equal to f dt. Okay. Now integrating both the sides, integration dp f dt. Here the momentum change from p1 to p2 and time is from t is equal to 0 to t. T is equal to t. Right. So this is the time part. Now what happen if we do the integration? We'll get that p from p1 to p2 will be f t is from 0 to t. T is from 0 to t. Right? Okay. I hope it's clear. So momentum change p2 minus p1 is equal to force into time. So which is the J, the impulse. So the impulse J, if we write here, is equal to change in momentum. So this is called impulse momentum theorem. This is very important. So you will get two different kind of numerical, like where sometimes you will get the force and time. If they ask you what is the change in momentum, so force into time is equal to will be the same value of the change in momentum. Or if you have the data of initial momentum and final momentum, if you subtract that, you will get the impulse. So both the way you can get the things, and also there is a graphical presentation like the force and time graph. Okay, force and time graph is presenting the impulse. If I am the if I am having a graph like this where x-axis always time, y-axis force. So this area will be the impulse. Okay. This is one more thing very important. So force time graph is presenting the impulse. Fine. Next is that this force may be constant force. This may be varied force. If it is in variable force, we'll take the average of the force initial and final, or we'll do the integration. Fine. So this is all about the impulse, and impulse is a vector quantity. Go through it. Any questions you can ask me in the same thread. Okay. Thank you.